really want to take this time to actually thank you guys for the turnout during the last reinvent recap panel meeting that you guys came in. You made it a big hit for us, and sincere appreciation for that. So without further ado, today we'll be talking about observability. Now, so we've got our awesome speakers, Mr. Adrian Tadros. He'll be talking about some basic building blocks about what observability is, talk about some frameworks and how you can essentially apply that in providing business value to the customers. Then we've got a sort of a demonstration coming up from the team in Datadog. So we've got Nathan and Oscar with us. So we'll be here on the second half of our presentations. And without further ado, Adrian, I'll hand it over to you, and let's push it.
Okay, welcome. My name's Adrian Tadros. I'm a solution architect at AWS. So really good to see you all. Really happy to be here to talk to you about observability.
Let's see, is that better?
Yeah.
Cool. So here to talk about observability. If you run any serious workload in the cloud, you know that being able to understand what's going on in the cloud is really, really important. So in this talk, I'm going to cover some of the foundations of observability and some best practices so you can get set up for success. So there's a lot to cover. I'm going to jump straight into it. So let's start with a simple definition. What is observability? It's really about understanding what's happening in a system. So asking questions like, is my system up? Is it down? Is it fast? Is it slow? Am I meeting my KPIs? So hands up, who here has ever had to deal with a production incident? Most of the room, right? So if we look at what typically happens when there's an incident or an issue, and we map out the timeline of events that happen from the time we detect it to the time we fix it, there's four main phases. So the first phase is really about detecting that an issue has occurred. And the average time it takes to detect that is what we call MTTD, or mean time to detect. The second phase is around identifying the root cause so we know what to fix. And that time that it takes is called the MTTI, or the mean time to identify it. And the overall time it takes to go from detecting an issue to fixing it, deploying a fix and verifying, that's called the MTTR, so the mean time to resolve. So those three metrics are really important to gauge how effective your observability plan is. And when we talk about observability, and what I'm going to deep dive into is the first two areas. So using observability to reduce the time it takes to detect and identify issues. So what actually happens during those phases? So in that first detect phase, if you're lucky, when an error occurs, you've got some sort of automation, some sort of alert that triggers when an issue happens. In a worst case, there might be an issue and it's actually, no one notices it for a while and it remains, no one's noticed it until there's a customer impact. Once you've detected an issue, you usually have a team there trying to identify what the root cause is, and they'll go and look at metrics. They might look at some stack traces and some logs, and really what they're trying to do is collect all that information to try and find out what's the cause of the issue. If you ever had to deal with a production incident, you might have a whole team of developers and ops and support staff all trying to do that, and it can get pretty chaotic. So to provide some structure and a consistent framework around observability, we refer to the three pillars of observability. And those three pillars are metrics, logs, and traces. And in this talk, I'm going to go deep into each of those, and we're going to look at ways you can implement those three pillars. In AWS, we have a service for each of the pillars. So CloudWatch logs for logs, CloudWatch metrics for metrics, and then for traces, we've got something called AWS X-Ray. These services all form part of CloudWatch. So CloudWatch is the one single platform that gives you basically a single pane of glass to see the operational health of your workloads in the cloud. So what I'm going to do now is dive deeper into each of the pillars, and we're going to start with metrics. So in AWS, there's two types of metrics. There's built-in metrics that AWS will generate on your behalf, and then there's custom metrics. So custom metrics are things that you define in either code or logs, and an example of that might be the number of orders that are coming through your system, or the total value of orders that come through an e-commerce system. In terms of the built-in metrics, the vast majority of services publish metrics to CloudWatch, and you may not even be aware of it if you haven't actually gone into CloudWatch. Maybe just a quick show of hands, who's actively using CloudWatch? Okay, so about half the room. So some of those built-in metrics can be things like the number of requests coming through your API gateway, the CPU utilization on an EC2 server or on a container, the number of times your database is being throttled, and the number of times your Lambda functions are being invoked. So those are just some examples. If you go into CloudWatch and click into metrics, you're presented with something called the Metrics Explorer. So this is an area where you can go and explore all the different metrics available. Metrics are grouped by what we call a namespace. So all of the AWS metrics start with the word AWS, and they're all grouped together. And if you generate your own custom metrics, they'll display at the top there under custom namespaces. So if you click into one of those namespaces, eventually you drill down into a list of metrics. So this is an example where I've drilled into Lambda as the namespace, and I picked one metric, which is duration. So the duration is the amount of time taken for a Lambda function to execute. When you pick a metric, you're able to graph that metric, so you can explore and see what that metric is over time. And you can apply some statistical functions, so you can do things like max, min, average, etc. Normally when you're looking at performance metrics, you use percentiles. So you might say, show me the P50 or the median value of this metric, or show me the P95 metric, which means 95% of the values are under that number. So that's really important to show outliers, because the outliers can usually skew your average. So showing one metric, in this example, I'm looking at only one metric, which is Lambda duration, but I'm looking at 3 different percentiles to give me an overall view of that metric. So you've got a lot of features in CloudWatch that allow you to view graphs and experiment with graphs. So yeah, percentiles is one way you can get a good view of that metric. So let's talk a little bit about dashboarding. So we've got, you know now that you can go into CloudWatch, you can view metrics, you can create graphs. The next step is usually to create a useful dashboard. So something that gives you a really quick insight into whether your application's healthy or not. So this is an example. I just want to highlight some key parts of this dashboard. So at the top there, we've got a list of key metrics, and in the top left, we've got orders. So that's an example of a custom metric that shows a business KPI. And then next to that, we've got a list of all of our errors. So it's really good in your dashboard, if you have right at the top, here is a summary of all the errors, so you can quickly answer, are there any errors happening in my workload? Under that, we've got more metrics which are around latencies. So in this example, I've got 2 Lambda functions to create an order and get an order. So those are the 2 main functions in this particular app. And we want to check, are those latencies looking normal? So if something's slow, you want to be able to see that immediately at the top. Then after that, we've got graphs. So the remainder of the dashboard is made up of graphs. And what graphs really help you determine is, are there any anomalies? So in this example, we've got a graph that shows the traffic coming into this app. And we can see that there's a dip in traffic for some reason. And it's also resulted in a dip in customer orders. So there's a business impact because of that. So immediately you can see that that's something that you should go and investigate. So dashboards are great because you can go in, you can see everything at once, but you're not continuously checking the dashboard every day. So the way that you can be notified when there is anomaly is using alarms. So in CloudWatch, there's 3 types of alarms. There's metrics alarms, which watch your metrics. So for example, if you're watching CPU utilization on a server, you might set an alarm that says, if my CPU utilization goes above 90% and is continuously at 90% for 5 minutes, that's reason to trigger an alarm. You can also do composite alarms, so that combines multiple alarms together. And you can do anomaly detection alarms, so that actually uses machine learning to look at your historical data and work out a common pattern of what your data should look like, and if it falls out of that pattern, then it can raise an alarm. So alarms can be in one of 3 states, so they can either be in an OK state, in alarm, or insufficient data, which just means the alarm doesn't have enough data to determine if it should be in an alarm state. And when an alarm moves into an in-alarm state, you can trigger an action based on that. So typically you might want to notify someone, send an email, and you would use Amazon SNS, so simple notification service, to do that. Or you might want to try and auto-rectify the issues. So it might be something like rebooting an EC2 server, or auto-scaling up an auto-scaling group, or calling a Lambda function where you can write your own code and you can do anything from that point. So in terms of alarms, I'm just going to talk a little bit about strategies around how to implement alarms. So one kind of naive strategy is every error should result in a notification. And what happens with that approach is it's not a good approach, because when you've got intermittent issues, people get bombarded with messages and they just tune out. So one way you can tackle that is by using something called tiered alarms based on risk and impact. So this is a really simple example of, we can set up different levels of alarm. So I might set up a P1 alarm, a high priority alarm. If that alarm is triggered, I want to send a page notification to someone's mobile app. So they basically wake up in the middle of the night and they have to get up and respond. But if I have a lower level priority alarm, I might just want to send an email if it's a P2 to an email group. Or if it's even lower than that, I might just want to post a message to maybe a Slack channel using a chatbot. So that's just one example of how you can approach that tiered levels of alarms. And when you implement that, there's a few different ways you can do that. So one is based on setting different thresholds on a metric. So in this example, we're tracking P99 latency. So what's the latency for 99% of my customers coming to my website or to my app? If that latency is going up and it hits a certain threshold, it might be worth alerting, because it's there might be something going on, but we might just want to send it to the Slack channel as an example. But if that latency keeps growing and the performance is getting worse, once it hits a certain point, we might want to escalate that and raise a P1 alarm. So this is one way you can apply those different tiers of alarms. Another more advanced way is if you're looking at multiple metrics. So in this example, we set a P1 threshold for our errors. So we might say, if I get a certain number of errors, that should be a high priority and we need someone to look at it. However, if I'm getting latency at a certain level, I might be willing to accept that the site might be slow, but if the site's causing errors and people are not able to submit an order, for example, I need people to prioritize that. So this is where you can have multiple metrics coming together to create those alarm thresholds. And I'll talk a bit about how you can combine that in a sec. So in some cases, when you're defining thresholds, it's really important to understand or agree on with your stakeholders what good looks like. So let's say in this example, you're running a website that has peak traffic during office hours, so between 9 to 5, and then after office hours, traffic dips. So you've constantly got this up and down, traffic pattern. So if you're using metric alarms, you might set a threshold for the high point and the low point, and anything that's in between that is deemed okay, but anything outside of that is reason to raise an alarm. But then you might have a situation like this where one day, for some reason, you've got a sudden dip in traffic, and even though you've set the thresholds, this is something that you should probably go and investigate, because it's not part of your normal traffic. So this is where anomaly detection comes in. So if you create an anomaly detection alarm, it looks at the overall pattern of your traffic or the pattern of that metric, and it tries to map out a dynamic threshold that fits that particular model. So in this case, if we see the traffic dip, it sits outside of that range, and then we can raise an alarm. So maybe you don't want to trigger an alarm straight away if it sits outside of that anomaly, and that's where you might want to consider a composite alarm. So in this example, let's say that you've got a whole bunch of services. You've got Lambda functions, an API gateway, but each one might experience a P3 alarm. So if one experiences a P3 alarm, it might not be an area for concern, but if all of them or a lot of them are doing it at the same time, there might be an underlying issue that you need to investigate. So in this example, we can combine all those lower priority alarms and raise a P1 alarm. So that was all to do with metrics. There was quite a bit we talked about, or we went through. So, exploring metrics, dashboarding, setting alarms. So let's look at the next pillar, which is all about logs. So Amazon CloudWatch logs is one central area where you can collect and store logs. There is a number of services. So for example, if you're using Lambda or an API gateway, they can automatically ship logs to CloudWatch logs. If you're running something outside of AWS, or if you're running a VM or a container, you can use an agent-based approach. So essentially running a CloudWatch agent, and that can pick up logs on that particular server and then send it off to CloudWatch. Logs can come in many different styles and formats, so from unstructured to fully structured. And when I say fully structured, I mean pretty much JSON format. And structured logs are always preferred because there's a lot of benefits to it when you need to query them and when you need to search through them. You'll see that when you use CloudWatch and you dig into logs, it will automatically extract all the JSON fields as attributes and then auto-complete them for you and things like that. So you can use regular expressions if you're not using JSON, but JSON will make your life a whole lot easier. So the way that you can gain insights from logs is by querying them, and we have a feature called CloudWatch Logs Insights. So what this does is it gives you a purpose-built query language that you can use to query your logs. Similar to SQL, so in this example, this is a really simple query to say, hey, give me all the logs, select two fields, the timestamp and the message, filter where the log level is error, and then sort by timestamp, limit by 100. So pretty similar to kind of how you would write a SQL query, select where, order by. This is another example. This is a query that can look at API gateway logs. So what we're doing here is actually applying a mathematical count. So we're saying, give us the total requests for each HTTP endpoint on the API. And then that produces a table there. You can then add that table to a dashboard, or you can go and create a chart from that and add that to your dashboard as well. And just to show the art of the possible, this is just a more advanced query that you can do in Log Insights. So this is a query that's looking at all of the Lambda functions in an account and producing, this is the number of cold starts each Lambda function had, and this is the amount of duration it took to start that Lambda function. So this query is it's extracting fields from the logs using regular expressions, and these queries can be really, really complicated, but just showing the art of the possible that it is a very powerful tool in terms of getting insights from your logs. So, question, how can I be notified when there's an anomaly in my log data? And the answer is, you need to extract metrics from your logs. And there's two ways to do that in AWS. So one is using metric filters, and one is using embedded metrics format, and I'll go through each one. So metric filters, what they do is when logs come into CloudWatch, you can set up a particular filter, and what that filter will do is filter out the logs to meet a certain condition, and then essentially publish metrics to CloudWatch Metrics. So then you can go and see those metrics in the Metrics Explorer. You can then go and set alarms based on those metrics. So in this example, number of errors. So what we're doing here is saying, if the log coming in has log level equals error, then let's count that as 1, and then that will go into the metric. So that notation there, $.log level equals error, the $sign means the JSON object. So if I've got a log coming in, then .log level means get the attribute called log level on that JSON object. If it's equal to error, then count that. The second example there, number of large orders. So this is just showing that you can use and/or operators and you can combine certain things. So give me all the logs where the total is over 1,000 and the number of products in that order is over 10, and that's a large order. And then the last example there is give me all the logs where the message type is order created, but instead of just counting that as 1, I want to actually extract the value of the order. So I'm extracting the attribute total from that log message, and that becomes a metric. The second option is to use something called embedded metrics format. So what this means is that when you write a log message in your code, if you include a certain format, so if you see in that JSON payload, underscore AWS, if you include a certain format, CloudWatch will automatically pick it up and turn that into a log for you. The recommendation is to use helper libraries. So we've got one library called AWS Lambda Power Tools. So if you're using Lambda, that provides you just almost like an SDK or a helper library that can make things much simpler. You definitely don't want to go and construct those JSON payloads on your own. Use the library to make that really easy for you. And then exporting logs from CloudWatch. So there's a number of use cases where you might want to get logs out of CloudWatch and store them in something like S3. One reason might be for compliance. Maybe you want to get your logs into another system for more processing or analysis. But also low-cost storage. So S3 is really cost-effective in terms of storage. And one thing to note is that if you're running Lambda in your account, the default retention period for Lambda logs is to never expire. So we've actually seen with some customers that they have accumulated a lot of logs for non-production workloads. So they've got a lot of logs sitting there. So that can add up over time if you're not careful. So it's just something to be aware of. Cool. So again, a lot we covered in logs. So we talked about querying logs, extracting metrics from logs, extracting logs into other systems. So let's move on to the final pillar, which is all about traces. So why traces is important? So logs and metrics are really useful, but they have one limitation, and that's that they look at things only at an individual service level. If you want to get an overall view of how your app is performing, especially when you've got modern apps that are decoupled, made up of microservices, this is where traces become really important. And this is where AWS X-Ray comes in. So it allows you to follow requests as they go through your app, and then identify any bottlenecks. So I'll step through some screens of what you see when you enable tracing in AWS. So when you turn on tracing and requests start coming through your app, X-Ray will actually generate a service map. So it's using something called Service Lens that generates a map of all the components and all the flows happening through your workload. So in this example, I've got 2 containers, a database, and an S3 bucket. You can then show on the service map the key metrics. So for this one, we're showing the throughput, so the average number of requests per minute or requests per second coming into each node. And then the latency, so the average time it took to respond. The size of the circles is important, so that gives you, in this case, it's based on the number of requests coming in. So that database on the end there on the right has 74 requests per minute. So that's the largest circle on the diagram. You can switch that between latency and throughput, and then you can see which ones have, you can highlight the ones that have the highest latency. And you also see there that some of the circles have a red line going through them. So that red line's taking up about a quarter of the circle, and that means that about 25% of that request coming into that particular node is causing an error. So it gives you a really quick and easy view to see where the hotspots are, where things are going wrong, which things are slower than others. And also it'll show things like throttling, if a service is being throttled. From that service map, you can click on a particular component. So let's say I click on one of the containers. That'll bring up some key metrics for that particular component. So the latency, the number of requests, the number of errors, and then I can dig deeper and even further into metrics and logs from that point. The other thing you can do is when you're looking at a service map, you can generally see, you're generally looking at the overall distribution of traces when you're looking at that service map. But maybe what you want to do is you want to dig into the outliers. So in this example, that chart is showing that the vast majority of traces that has been captured, the overall response time was under 2 seconds. But what I've highlighted there in the chart on the right is the outliers. So those are some of the traces where the response time was over 6 seconds. So if I highlight that section of the graph, I can dig deeper into those individual traces. So I can see that there was 3 traces that were captured where the response time, it's sorting by response time, the highest one there is 10 seconds. So I can actually go in and click on that and dig deeper into what's happening in that individual trace. So when you dig into an individual trace, this is kind of what you're presented with. You see at the top there a diagram of all the components in that flow. So this is an example of a client talking to an API gateway, to a Lambda function, and then to a DynamoDB database. And then you can see under that, like almost a Gantt chart of a series of the time it took to complete each step. So you can see the time it took to invoke the Lambda function, the time it took for the database to return. So you get a breakdown of exactly what's going on in that trace. So if you want to enable tracing in your app, there is a lot of services, especially the serverless services where it's just config driven. So you can go into the console and tick a box to turn it on, or if you're using infrastructure as code, it's just a flag in your code to turn it on. And similar to CloudWatch logs, if you're running something outside of AWS, you can run an agent, and that will also listen for X-ray traces and send that off to X-ray. So one last thing with X-ray and traces, let's say you've got a typical architecture in AWS. Here we've got an API gateway, some Lambda functions, SNS, and a DB. What we've been looking at is the trace, so going from one end to the other. And then when you dig into that trace, you see the segments, so the actual flow of data going between each of those components. If you want to dig even deeper, you can look at sub-segments. So in this example, let's say a request comes in through the API gateway, hits a Lambda function, but that Lambda function is actually doing a lot of things. It might be talking to a third-party service. It might be doing something really compute-heavy that's eating up a lot of time. That's not really reflected in the segments. So this is where sub-segments come in. And the way sub-segments work is you basically instrument your code. So if you instrument your code with the X-ray SDK or the Lambda Power Tools, you can then kind of in your code identify when you're doing a certain task. So this is what it might look like. So in the previous example, we looked at a Lambda function. It's basically said when the Lambda function was invocated, when the DynamoDB table was hit. So we saw a couple of items in that trace. But when you enable sub-segments, you actually get a lot more richer detail about what's happening within that function. So if you want to drill deeper into a particular area of your code that's problematic, this is kind of how you can identify it. It gives you a quicker way of finding where your bottlenecks are. It does come at the cost of, you do have to implement the code to do that. But you can see the benefits of kind of identifying where your bottlenecks are within that function. The last thing I'll mention about X-ray and about traces, there's one opt-in feature called X-ray. So it's really useful to quickly identify what the problem is. It's also really useful if you need to report back around this was the impact of this outage, of this incident. And digging deeper into that, you can click on that insight, and it gives you a full breakdown of what was the service that was the root cause of the incident, how long did that incident last, and a graph showing you kind of where it found the anomalies that triggered that insight. So really useful to quickly kind of get information. Cool, so quick recap. So we talked about the 3 pillars, went into some of the different services. I'll just, in terms of the wider AWS observability toolset, so this is the overall toolset that AWS provides. On the left there is all of the native services, and on the right we've got managed services that are open source products. So the most popular being Prometheus, Grafana, and OpenSearch. So what we've talked about in this session is really just a few of the native services. And the reason I'm only focusing on the native services is that for the most part, a lot of them are just will work by default or already working by default, even if you're not aware of it. So the barrier to entry is pretty small. You can start using them fairly quickly. The other services that we haven't touched on there, so things like synthetics and RUM, a way to kind of another way of looking at those services is through this lens. So this is the AWS observability stack, so the native stack. And what we've really covered is the foundations in this talk. So I've talked about metrics, alarms, etc., that are all at that infrastructure level. But at that digital experience level, there's even more that you can do. If you set yourself up with the foundations, you'll be in a great position, but you shouldn't stop there. If you can look at synthetics and RUM, I definitely recommend it. So as an example, synthetics is really about simulating users accessing your application from the outside. And then RUM, or real-time user monitoring, that's really about measuring latencies and what users are experiencing at the device level and at the browser level. So hopefully, this is the kind of troubleshooting workflow I presented earlier in the talk. Hopefully, using the tools that I've talked about, you can kind of get your workflow to look something more like this, where you've reduced that time to identify issues. You've got automatic alerts, to detect issues in the first place. And then when you go into identify, you've got a nice service lens, you can see all your services. You've got a more structured approach to kind of dig into metrics and logs and find that root cause. So where to from here? I definitely recommend, if you're keen to get into this observability space, we've got an observability workshop that I highly recommend. So with that workshop, it'll take you through deploying a sample application, running a load test on that application, and then using all of those tools. And that's including the foundations that I talked about, but also synthetics, RUM, and even the open source stuff. So you can pick and choose which ones you want to go deep into. If you have an account team, so if you work with an AWS account team, architects like myself are more than happy to work with you on that, and they can run that workshop with you. And we've also got tons of partner solutions. So I haven't even touched on the partner solutions. We've got Datadog talking after this. So we've got some native solutions that integrate with Datadog, Splunk, AppDynamics, New Relic, you name it. And yeah, my last kind of parting thought is definitely just get started, get your hands dirty. You're not going to get it right the first time, but also having some ambassadors in your organisation to really take charge and lead the charge. That's really the way to go. So thank you very much. Thanks for coming along today.
Has anyone got any questions? Fantastic. Okay, cool. I'll chip in Oscar and Nathan to jump in.
1 second. Just as a quick show of hands, how many people here are familiar with Datadog? Okay, how many of you have used or are using Datadog? You can't put your hand up. She works with us, that doesn't count. Okay, cool. That gives me a good kind of overview. How many sales engineers does it take to work a screen? Oh, you gotta go. Yeah. Awesome. Okay. Welcome. My name is Oscar. I'm one of the sales engineers here at Datadog, and this is
Nathan.
perfect. It's like a little duet. So we're from Datadog. If you're not familiar with us, we're an observability platform that is very similar to a lot of the material you've already seen tonight. We kind of extend on a lot of that. And we can cover your metrics, your traces, your logs, pretty much all of your telemetry data into a single platform. And of course, we integrate very well with AWS. Now, the plan for today is we are going to try and get you guys to knock over an application we have set up. So if you scan that QR code or go to that URL, you're going to be taken to a website that we're hosting that is essentially where you enter your Myers-Briggs personality type. It was either that or horoscopes, so we went Myers-Briggs. You enter your name, click enter, and then submit which type you are. Now, because you were all nefarious black hat users in this scenario, and I haven't put a disabled state on the button, especially if you're on a computer, this is going to be easy. I would like you guys to just keep hammering the submit button, and while you're doing that, we're going to get a lot of information coming through. We're going to kind of live analyze what's about to go wrong. Full disclosure, Nathan and I actually don't know if this is going to fall over. We added in a prime number calculation into the API just to slow it down. But yeah, we'll see how it goes.
Yeah, we've done a bit of a cardinal sin in demonstrating, which is we don't have a plan. Our plan is to see whatever happens, and that's kind of it. But basically, as we're starting to go through the application itself, so let's actually go ahead and scroll here. What we see, what we see here is the Trace Explorer in Datadog. This is, I guess, one sort of key point to highlight here is we don't really like query syntaxes. We just basically utilize tags.
So one thing, if you start seeing red, you've done a good job. Thank you, you can stop. I don't know how long, if that happened instantly, or it took us a long. Okay, we got red. Perfect. All right, we'll go. Thank you very much.
Oh yeah, and whoever mashes the button for the, how long are we doing this for?
Yeah, let's do it. We'll go through retroactively just to see.
Okay, all right. Whoever did mash the button, we probably should have opened with this. We'll get either a Datadog, what brand are these? Yeti, or a Datadog T-shirt, both very highly sought after.
Get healthy requesting before we knock it offline. Whoever got the most in before you all manage to kill it is we'll be getting.
That's why we needed some unique identifier from you guys. We're not going to hammer you with questions around or marketing stuff because you put your name in. Don't worry. So, I mean, we've obviously got quite a few traces coming through here. So let me go ahead and pause them and see what's going on here. And a lot of what you just saw with X-ray, for example, is going to be utilized in Datadog as well. So utilizing, for example, creating spans and traces from API Gateway and from Lambda. We have a Lambda extension that will trace it as well. But the idea being that as we are going through, for example, one of these traces, we see the full distributed trace in more of a visual view. So it's a bit easier to coordinate as we're going through the stack what is going on here. So we have actually implemented real user monitoring, so that's how we're tracking.
Zoom in a lot.
Sorry?
Zoom in.
Oh, with my mic.
No.
Okay. I was like, okay. Oh, okay, I can just do that.
That's it.
So, thank you. So effectively what we see here is the distributed trace, and we've got real user monitoring, which is just a bit of JavaScript that sits on the front end, monitoring your actions as you're coming through the platform. It's also allowing us to correlate it through as XHR and fetch requests from the front end through to the Datadog tracer. So it's passing through a Lambda function that we have set up, which is also making a request out to my SQL database, which is also making a request out to, for example, an Express application that we have running, which is also making a request out to a database. So we're basically seeing this full series of events in this visual view. Now let's say we want to understand what's actually happening at the infrastructure level. Well, we can go ahead and scope into, for example, this Express application, jump into infrastructure. Let me just scroll up a little bit further up. If we had a containerized architecture, Kubernetes, or whatever else, we'll go ahead and see that spike in CPU utilization, for example. We'll also correlate that through to memory usage, RSS memory in containers, whatever else. The idea being that you don't need to be jumping through different contexts, searching different timestamps, searching for a trace ID or anything like that. It's all correlated here for you. Same for serverless contexts, where if you go into Lambda function, how many invocations do we have as fed by CloudWatch? So a lot of what we're supplementing from CloudWatch, and we're building on top of that through a Datadog agent that's sitting in your environment, and correlating these metrics together for you as well. So it looks like we peaked peak of about averaging 40 executions concurrently. Doesn't look too worrying. I know that I set that limit very high, actually about 500, so I'm glad we didn't get too close. And we also have our application logs. So what we're doing is we're injecting the trace ID through the Datadog tracer into your application logs. So it's all tied together nicely for you in one place. You don't need to be jumping through different places. Now, just to highlight as well, in this particular context, if we jump up to this browser request, we can get a walkthrough effectively of what this session looked like from the perspective of real user monitoring. So what we're seeing in real user monitoring is that collection of front-end events, effectively. So filling in input information and clicking on buttons, and you can define custom actions as well.
Shout out to whoever CC is, because you really hammered the hell out of them. Whoever CC, thank you.
Good stuff. We can actually, for example, drill into the submit, and from that front-end action that they took, correlate it through to the back-end itself. So we see that distributed trace going through, your full platform. So with this, we can actually see we've got an error here. What is this error? It's probably just, Lambda throwing an exception there. We got our log information. We saw that information earlier on as well. We're also collecting process information from, for example, the more traditional architecture that we had. I'm used to using a mouse, so forgive me while I poorly zoom in on this.
It's like surgery.
Yeah, it's not going well. So when we scope over that, basically, we can also collect, for example, process information. It's obviously a very thin sliver in our Express application. Here we go. So most of that duration, actually, that API responded incredibly quickly. We have, for example, we can see a MySQL database that's running on there. We can see the node application, what usage looked like from CPU and memory. So the idea is, effectively what we're doing is pulling all this information into one place. We want you to be able to access it easily. We want you to be able to access it without needing to learn a query language. And we want to sort of expand and expound upon it as well. So you might be tracking some, for example, more business-related metrics rather than purely technical metrics. You can dashboard this kind of stuff out and share it with whoever you need to. So I think what we're going to do now is take a quick step into, it doesn't actually look like it fell over as such, which is slightly disappointing.
Yeah, we only got to 50%.
We should have made the prime number calculation a little bit.
You got red?
All right.
I wanted to just keep the whole thing.
Let's jump into a bit of a further deep dive. In that case, let's actually go ahead and look into, for example, CPU usage by process. I mean, it doesn't look like, doesn't look too terrible. Has this updated? I'm just making sure that we're, as I said, cardinal sin. We should probably have prepared this better, but we wanted to make it a bit more interactive so that you guys can actually see information flowing through, rather than relying on our demo environment. In this case, Amazon SSM agent has actually utilized more of CPU usage than our Node application that was running on there, and MySQL. This is unexpected.
This is not what happened in our trials, but
Yeah, so I mean, one other function that I do want to highlight though is if we go back to this graph, we see each of the service requests, obviously, starting with your golden signals, being able to derive, for example, what's actually happening there. So jumping into the traces for that particular request. We can also scope into other metrics that we have, for example, which we might be able to utilize for correlating to other metrics. So in this case, do you want to work out who the winner is?
Sure.
Yeah?
There was one other thing that I wanted to show as well. A lot of what we've spoken about today is kind of focused on purely DevOps, but this is a tool that you can have other members of your team use. One example that we see a lot is giving this to your support staff. So maybe your support staff reach out and say, hey, someone's logged in, they are trying to go to their profiles page, or they're trying to go to the dashboard and they're getting an error and we don't really know what's going on. Well, through Datadog, we can actually go to UX monitoring, which is RUM, go to sessions and replays. And because I have that information and you guys put that name in, I've now associated all those sessions with a name. So the common way of doing that is when the user logs in through the RUM SDK, you just start tagging the session. And if the demo gods are kind to me, we will have a user information here and then user name. And now I can actually go through and filter through all these sessions. Someone tried to do a little bit of SQL injection, hey? Think we didn't catch that? Yeah, nice one. Little Bobby drop tables, okay. Well, that's, at least it did not go over, so that's Datadog security for you. So now I can actually just click on Eduardo's session, filter it just to them, and now I can replay the session and the actions that they took. So this is incredibly powerful, especially from a support point of view, or even just like, I don't know, we notice a lot of companies where like their PMs are using this. So they're trying to understand why users are having points where they're falling over, or they're trying to convert something and then at some point the whole thing dies. Well, this is a great way to address this. Now, that was all I wanted to show. Should we do questions at the end?
Yeah, sure.
All right, questions at the end. I'm just conscious of time. I know there's like a whole thing of pizza and beer out there, so I'm stopping you from getting to that. Well, let's go to who actually won. Where's the dashboard? What's it called again?
Dashboard list.
Bum, bum, bum.
I don't remember what it was. Oh, it was AWS.
Sweet.
You will get AWS dashboards for pretty much most of the resources that AWS provides. So you get that out of the box, which is always nice.
Cool. So now we want to try and figure out who managed to get the most requests in the first minute or so. I think it kind of...
The top three.
We're in top three? All right, let's have a look. So we're going to add, what do we want here? We're top list. So this is just the widget creator, pretty similar to any other widgeting tool you've used, I'm sure, but just entirely based on our key value pair system that we use, which is like AWS tags, same concept. So now I'm going to change the data to be based on APM, so this is our traces. Now I'm going to, actually, could you type filter it rather than me one-handing it? Okay, so could you do service, and we're going to do AWS user group. So this is obviously the service we're looking at now. So we're getting all of the traces here, 906. That's not really what I was trying to achieve. I want to know how many traces each person did. So what we can do here now is group by that user ID. So that's going to be at user.name. There we go. Brad. Holy hell. Where's Brad?
That's...
Oh man,
All right,
you really...
well done.
Well
Would you
done.
like a t-shirt or do you like a Yeti mug?
I've got one of the Yeti mugs, so I'll go.
All right.
T-shirt?
We'll grab it afterwards.
Yeah, we'll do proper sizing.
Joseph, is that you?
Is that you? Oh, okay, he works here, that's not allowed. Ishida, next one. Oh my god, it's just the trio right here. Okay, perfect.
And AJ.
AJ up the back. Could you three at the end of this please, oh, no, you've got the phone alarm going off. Oh no, it's a disaster. I don't remember putting that on the website. So could you three please go up at the end and we'll give you the shirts.
But let's just, I'm curious. curious actually to see if we did get any errors, because it just seems a little bit unusual for it to not have any errors whatsoever.
We definitely got that.
Yeah.
Here we go.
So we're getting like, oh wait, there was 650 errors. So my guess is, honestly, we had a lot of issues when we were setting this up a few hours ago in my head with cause. Seriously, we do not enjoy cause.
Just for context, I used to be a front-end engineer, and then I quit and became a sales engineer, so I didn't have to deal with cause anymore. And then I had to do cause today, so it was a bit of a sensitive topic for us.
So, okay, in this case, actually, for example, the lambda function was close to timing out. I set a 5-second execution limit, and our Datadog extension here has picked up that actually we're about to time out. So it's thrown that error so that I have that additional context to know when I'm triaging what's going on. Now, in this case, we can actually also set, of course, monitors. I'm not going to go into huge amount of detail here. Actually, the previous presentation did a pretty good job of what monitors look like within Datadog. So we have a lot of similar capabilities in that regard. We would scope into that particular service, which was AWS using Lambda. And actually, in this case, we call it service, AWS using Lambda, I think it was. And we just do status error. We can also scope into a certain message type. So it could also be like error.message. To then say that I want to look for this particular error that we're grabbing and notify out to Slack, to PagerDuty, to Teams, whatever else you need to do. But in other instances, and especially in this context, where we're getting 100, what was it? I can't remember what the peak number of requests was. It was like 100. It was close to 200. We probably want to stop that user from trying to abuse our API. So we actually have some functionalities around that I might just very briefly go through. We have expanded, so Datadog started off with more of an infrastructure focus, then we added APM, then we added logs. But with this, we've also now established that, well, if you're sending logs to Datadog, then we may as well add a scene product on top of it, because that would be a logical continuation of it. If we're already integrating with AWS's API, well, why not evaluate that with compliance frameworks that you're likely to have to adhere to? So we've added a host of security suite products on top of the observability piece that you can further use within this one single platform, effectively. Now, we are moving towards auto remediation. So we announced a couple months ago a beta for workflows, which, for example, allows you to, let's say, based on an IP address that we're receiving requests from, set up a blueprint to ban that user IP in an AWS WAF. So based on a monitor or a security product alert being triggered, we can go ahead and integrate with AWS's API to scroll down to WAF and add an IP to ban them from it. So we can set up effectively, automatically, workflows to take your workload and reduce your workload is what we're trying to achieve here. Set up your own workflows to integrate with Jira, to integrate with various other services out there if you're delivering it through Cloudflare. And also, for example, even your CI/CD pipelines, pull that information into Datadog and monitor all things in advance. I can continue talking about this forever, but I'm just going to cut it there because I don't want the piece to get cold. Feel free to reach out to any of us, whether it's Oscar, whether it's myself, any of the Datadog people who are wearing Datadog t-shirts. Not many.
Actually, none of them are. So that'll confuse it because we're giving shirts away. So don't talk to the people in the Datadog shirts, I think.
But feel free to have a chat to us about any of the products, and we'll be more happy to help you there.
Were there any questions? I know it is past 7, but yes.
Yeah. Do you have like a Terraform provider or something?
Yes, we do.
Yeah.
You can actually instrument a lot of this via Terraform, which, yeah, it's pretty cool. There's not, I'll be honest with you, it's not 100% support for everything you can do within the UI, but a lot of the key concepts you can instrument via Terraform.
Yeah, all the dashboards, all the monitors are basically based on objects in the background and the resources in the Terraform provider, so you can actually set up observability as part of your infrastructure as code.
So do you find a lot of customers are just using the UI? Well,
it depends. One of the use cases I see the most is for B2B customers where they have like, maybe a school signs up to them, they'll specifically spin up infrastructure in AWS, like they get their own VPC and their own EC2s, and then as a part of that, they also spin up dashboards, monitors, and alerts, all from the same bit of Terraform. It's pretty common. One kind of cheap thing that I think is a good thing to do is build the dashboards in the UI and then export the JSON. Don't try and build the dashboard in Terraform because that's just like, it's asking for madness. So yeah, that's the better way to do it, I think. Were there any other questions? Yes.
Are there like SDKs for do you have a REST API with a lot of language support, or is it just?
As in for interacting with the UI or for instrumenting APM?
For interacting with the UI.
Yeah, we do have like REST APIs that you can interact with to like create monitors or get a list of services or stuff like that. Yes. Was there another one?
Sorry,
Yes.
just a follow-up. So we have SAP for APM as well.
Yes. So, how many languages do we support now for APM? It's pretty much all the big ones, as far as I can remember. Here we go.
So, it depends on your architecture as well, but all the major ones are generally going to be covered. For example, Kubernetes and even Docker, for that matter, we're also adding instrumentation while the services are live as part of the Kubernetes operator, I think it is. So you don't even need to redeploy your containers. And we also accept OpenTelemetry as well. So if you use OpenTelemetry, send that into Datadog.
Perfect. Another question?
Yeah, with the
Front-end monitoring, UX monitoring,
no.
APM. I'm going to list every product. Workflows. Workflows. I forgot as well, and I just watched it.
With the workflows, if a step goes wrong, you have sort of alerting and stuff that goes on.
So if workflow execution fails?
Yeah.
So full disclosure, this is still a private beta. I actually genuinely couldn't tell you because I got this enabled by the product manager 2 days ago. I haven't really had a chance to play around with it too much. I do know that there is like looping, so if it fails, for example, you can get it to retry based on that. So my guess is actually yes, you can have some conditionality around the response that you would expect to receive.
That's it. So you create a custom workflow with the
Yeah, and it can go to a webhook. It doesn't need to be a pre-existing integration.
Cool. Oh, yep.
What's the impact on the performance?
For like APM, for example, a service. So we do internal benchmarks on that pretty much every month. It differs for what framework you're using. The average is between like 0.5 to like 1.5% increase in latency, and the same goes for the agent with like CPU overhead. So full disclosure, Datadog uses Datadog to monitor Datadog. Sorry, that came out insane. But yeah, we use this on all of our production instances, and everything is enabled, and it performs at insane load. So yeah, I've never had a customer have any issues with overhead personally.
We have most of the largest cryptocurrency exchanges on Datadog, to give you an idea. But there's another product which I didn't highlight today, which is Continuous Profiler, which is designed to give you sort of a method level breakdown of what's going on in code. If you've actually got the GitHub integration enabled, then you see the code line level impact on that performance as well. So that's obviously going to have more overhead, but it is actually designed to run continuously in your production environment. So it's not something that you enable for 10 or 20 minutes.
And you can also see that little bit we added in calculate primes was causing a lot of issues. As you can imagine, calculating primes when you're handling an API request is not a good idea. Sorry, any other questions? Nada? Okay, perfect. Well, thank you very much for listening. Hope that was beneficial.
Thank you guys for your patience. Just wait quickly. Just a curious question. How many of you are interested in FinOps?
Yes.
FinOps. Is anyone interested in FinOps? Yeah? So that's exactly what's going to happen next month. So I wish you guys to see you again next month. But